Hey everyone, welcome back. Professor Hank here. Today we're going to talk about Python modules. We'll talk about what they are and how we can use them. So let's go ahead and get started. So when you write a Python program, you're typing all of your code into your IDE such as idle, and then you save that file. Now that is known as a script. So when you save a bunch of statements in that file, that is a Python script file. Now, if you have a simple program, that may be all that you need, but it could be the case that you want to reuse a bunch of that code. And so what you can do is you can save that file and you can then reuse that in another program. So when you save a script with a bunch of code that you want to reuse, we're going to call that a module. So a module is a file that contains Python code that other modules can use or other scripts can use. So how do we use the module? Well, we access the code in that module by using an import statement. And don't worry, we're going to see how to do all of this in just a second with a coding example. Now, once a module is imported into your program, anything that is defined inside of that module can be accessed using dot notation. So we'll see how we can use that to get things done. All right, so let's go ahead and take a look at some code examples. Okay, so let's say that we were going to write a program that was going to calculate the area of a shape. So we might ask the user for the radius of a circle. So we'd have something that looks like this. And I'd say enter radius. And then once they've entered that radius, I'm going to need to calculate my area. So we're going to have area equals, and it's pi radius squared, pi times radius squared. So I'll use 3.14159 as an approximation for pi times radius squared. And then I print my area. So I'll say something like print area is, and then we'll print the area. And so I save this file. And this is an example of a Python script. My program is saved as a Python script. It's a collection of all my statements in a plain old text file that make up what my program is going to do, all those different statements. So I go ahead and run it, and then I enter in for the radius, say 1.1, and you can see there is the area. Now I look at my code, and 3.14159 is pi. Pi is never going to change. And it's a good idea whenever you can to avoid using just literal values like this, especially if they have a specific meaning. Because sometimes when you look at a literal value, when you're examining the code, someone who's looking at it might look at that number and go, I don't know what that means. So it'd be a good idea to avoid having that magic number and creating a constant. And constant variables are usually spelled using all uppercase by convention. Characters. So we do something like this. We say pi equals 3.14159. And so I'll replace that instance of the literal pi with my variables. Now when you look at area equals pi radius squared, it's a little bit more readable, right? And then I can just reuse pi anywhere I want inside my code here. Now if I run this, it's going to have the same result, but the code looks a little neater. Now, here's the thing. What if I want to reuse some of this code in another script? Maybe I don't want to have to redefine pi in every single Python program that I run. Well, what I can do is I can put this in its own separate Python file, which we'll call a module. So I'll create a file that I'll call constants. And so any constant value I'll store in here. So I'll go and I'll take that pi and I'll take it out of my script and I'll put it in constants.py for reuse by any script that might need that. Now, if I go back to my original main.py and I run it, of course, it's going to freak out because pi is no longer defined, right? So what I'm going to do is I'm going to import that module, that constants.py. So module's got code that you can reuse over and over and over and over again. So the way I'm going to gain access to that code is I'm going to use the import statement. I'm going to say import constants. And it's just constants, not constants.py. Python ignores that extension. Okay, so once I've done that, I can now access anything that has a name in that file constants. So if we go back in there, that variable pi has got a name. So I can go into my main.py and I have to specify which module contains the thing I want to use. So constants.py. So now if I go ahead and run this, you're going to see that it's going to work just fine because I've gained access to that value that's in my module, right? So module, just chunk of code that's related in some way that you can reuse in other Python programs. Now, when you do this import statement, Python is going to execute all of the code in whatever it is that you're importing. So in this case of our constants module, it's going to execute whatever's in there. And you might have some code in there that you don't want to execute, because you can actually import scripts too. So for example, here's what I mean. You know, if this was a completely different script, completely different program, and for whatever reason you had the pi in there, and you also said, hello world, pi is pi. Right? I can run that on its own, and it's acting as if it's its own script, right? Now, if I go back to my main.py and I imported constants, and I go to run this, I'm going to see that hello world, pi is 3.1. I don't want that in my circle area finding program. So the way we get around that, or the way we deal with that, is we use this little test. And when you run a Python script as its own program, Python is aware of that, and it sets this variable implicitly called name to a value to a string main. And so you can test that to see if this is being run as a script, as a program. So, and if so, then go ahead and execute all of the statements that are part of that program, otherwise don't. So it allows you to kind of use a script as both a module and just a regular program. So what that looks like is something like this. I can say if name equals underscore main, and then I indent just like this. So if I run this as its own program, you can see that it executes as you would expect. Now, if I go back to my main.py, and remember, all I wanted out of that constants file was the pi. So now if I run main.py, this is the script, this is the program that's running, not constants.py. Constants.py didn't get executed as a program, main.py did. So that's going to cause in constants.py this to evaluate to false, so this code is not going to execute. So I get access to the pi without seeing any of the code in here. So let's go and see that in action. So F5, you can see that that print statement didn't execute from constants.py. I got access to the pi variable, so I do my 3.1 or whatever, and everything works just fine. So a couple of details to finish up here. One is that if you want to import a module or a script into another script, then you have to have all the files in the same location, or the files have to be in the same path. The Python standard library contains a collection of useful pre-installed modules. Modules are fantastic for helping you to reuse code and also to organize your programs into logical subunits. Modules also become more useful when we start talking about functions and classes, where it's a little bit easier to organize things in a logical way. So that's everything that I wanted to talk to you about in this video. As usual, if you're a student of mine, you have questions about any of the topics covered in this video or any of the videos in our courses, please feel free to email me via Canvas or stop by our Zoom office hours. Thanks for watching, and we'll see you next time.